So using the differential form of RTT, I was trying to derive the equation for density. So this is the differential form of RTT. I want to choose the entity to be mass. The corresponding phi becomes density, becomes a scalar. And then R2 is the rate at which the mass residing inside the control volume will change due to non-advective reason, that is 0 according to law of conservation of mass. So when I substitute phi by rho here and set R2 as 0, this is the equation I got. So towards the end of the previous class, in hurry, I wrote this as x1, x2, x3. No, that is v1, v2, v3. It comes directly from here. So please don't talk. You have come late and then talking also. So this is what I derived towards the end of the previous class using RTT differential form. Then I am applying product rule of differentiation for these individual terms here. So these three terms give me 6 terms. I take this one, and this one. I keep them on the left hand side. The other new 3 terms I push on the right hand side. The reason I keep the 3 terms on the left hand side I recognize that these 3 terms actually represent this. You can call this advection of density, advection of rho. This whole term can be called the mathematical representation of the advection of rho. And then I realized that the advection term plus the partial time derivative term, that can be clubbed together and written as the material derivative, right? Material derivative. So this is the simplest form in which we represent this equation. There are various names by which we call this equation or refer this equation. We call this equation sometimes as the transport equation of density. Transport equation of density in Eulerian description. Sometimes this equation is also called, either this one here or here, both are the same equations actually, just the change in all. I have put capital D, otherwise the equation is the same. That is also called the continuity equation. Continuity equation. What kind of equation is this? What kind of equation is this? Is it an algebraic equation? Is it a differential equation? The differential equation. Now, even in differential equation, there are 2 types that we know about. One is what we can call as the ordinary differential equation. The other is the partial differential equation. Clearly, this is partial differential equation. Right? If you know somehow the background velocity field, V1, V2, V3 everywhere, then you can think of solving this equation. For what? We'll solve this equation for what if V1, V2, V3 are known? For density. All right. Actually, sometimes this is also called just equation of rho equation. Third type, rho equation. So if V1, V2, V3 are known, we can think of solving this equation. But who will tell us what V1, V2, V3 are? We need to find a governing equation for velocity as well, right? In fact, that is in line with what problem we pose for ourselves. We need to have governing equation for rho, velocity vector, pressure and temperature. So it's logical now that we try to derive the governing equation for the velocity vector. Okay, that is the next item on our agenda. We'll talk about it. But before I go there, let me draw your attention to something that I wrote here before all of you came in. I want you to have clarity how we have written the Reynolds transport theorem. There is a control volume. Actually, after the morning class, one student was asking me a question and I felt like I should make things more clear. So this is a control volume. This is a reference frame. Reminding you What is n? N is a tensor in general, and n is actually a given entity, how much of that is currently residing inside the control volume. So if entity is mass, I'm asking how many kgs of fluid is right now inside the control volume. That question is sensible. Then I ask how much momentum is right now residing in that control volume. And then I ask how much energy, total energy, is residing in that control volume. Are these questions sensible? Do they make sense to you? How many joules of energy is there inside? Now, whatever energy or momentum will be, they have to be associated with fluid particles. And indeed, that control volume is full of fluid particles, right? That's why I can ask this question. And the way to get this, how many kgs of mass, how much momentum is there, this is the way to get it. You perform a volume integral with phi here. What is phi? Entity per unit volume. And that's why entity per unit volume of fluid, when multiplied by dV, which is a small infinitesimal volume we will take here. Once you do this multiplication, you get how much of the entity, how much mass is there in this. And once I have that, I need to just spread that integration. I mean, I have to do this summation over the whole control volume. That is the volume integral. Is it clear? Now my next question is, at what rate that amount of entity which is right now there, at what rate it is changing? It has 5 kg of mass right now. At what rate it is changing? Maybe next time instead it may become 5.1 kgs or 4.9 kgs, right? I want to know that. But before I know how to get that, I want to write a mathematical expression for that, simply mathematical expression. Instead of writing these many words, I want a mathematical notation for that. That mathematical notation is this: partial with time. Okay. Why partial with time? Again, because this control volume, if taken to a different location, it will have different n. All right. I just want to keep the control volume there. I don't want to change its location, but only monitor it, monitor the n contained in it. So how is that changing with time? So I use the symbol. This is just a symbol. And the unit of this will be, of course, entity per second, kg per second, momentum per second, or joule per second. I keep it on the left hand side. I'm trying to build an equation here. I keep it on the left hand side. Now to build the equation, I need to know what causes that change. Does it make sense? What causes that change? If I can mathematically write the expressions for what causes this change, I have an equation. All right. Now when the question comes, what causes this change? I am saying of all the causes that are possible, I categorize those causes into two groups, R1 and R2. What is R1? R1 is the change that will come to N because of advective flux. It's like you take a container, you fill some water, there is some amount of water, I open a tap. Water will drain, right? This is flux. Advective flux taking some water out. And then one can say that I will have another tap at the top which brings in some water. So from top there is a tap which is bringing water, at the bottom there is one which is draining, right? This will be draining, so it will have negative effect. This is bringing in, so it will have a positive effect. But then my control volume is not a container, physical container, it has transparent walls. Water can come in from any point and get out also from any point on the surface of the control volume. All right. Accounting for all that gives me this expression. On a surface. Which surface? Surface including the entire control volume. So that's the mathematical expression for R1. But that's not all. There could be some other reasons why the amount of entity contained in the control volume can change. And that depends on the nature of that entity and how nature generates that entity. If it is bacteria, how nature generates more bacteria by reproduction. So R2 is a placeholder that will bring the mathematical form of the rate of reproduction of bacteria. That is not advective. I hope you will agree with me. Because if I go back to the container, I close both the taps, and if the water is dirty, it had certain number of bacteria. You come back after 10 minutes, the number of bacteria would have changed. No flux, but it has changed. By what? By a mechanism that nature has given to the bacteria cells to generate more of themselves. That is reproduction. Right? When it comes to mass, if both taps are closed, you keep 1 kg of mass water, you come back after 5 minutes, you can't expect that amount to change because there are no nuclear reactions here, it cannot change. So for mass, R2 will be 0. Right? If you talk about momentum, all taps closed, this much is the momentum, some momentum had, the full fluid had. At next time instant, that momentum will change or not change. It's governed by what? We know as much we know about nature, we know that there is an axiom which tells me how the momentum which is inside the control volume will change because of non-advective reason. And that is, you draw the free body diagram, net force acting. On what? On the mass that is inside the control volume. That's the mechanism by which nature generates more momentum. All right. And when it comes to energy, similar reasoning is there. If I keep this much of energy in a container, I come back a little later, it would have changed, all taps closed. It would change if somebody has done work on that. And it can also change if somebody has added heat to it. All right. So when entity is energy, R2 becomes W dot plus Q dot. That's what I wrote. Such is the idea. Now, today morning and in the previous class, I was trying to give you a way to visualize or to kind of narrow down or identify what R2 will be for different kinds of entities. For that, I told you that imagine for a moment V is 0. In reality, it's not 0. I am asking you to do this because it helps you understand whatever I have said so far. It's only for understanding. In reality, V is not equal to 0. So both advective flux and R2 regions are working simultaneously. But to help you understand that, I gave you a kind of a mental exercise. Take that off, which is like close the taps. नीचे वाला ऊपर वाला दोनों टैप बंद कर दिया. अब सोचो कि क्यों बढ़ेगा, क्यों घटेगा. For that, I gave you this way of deciding. If you followed the first part of my speech and you are able to understand what R2 would be for different types of entities, you don't need this. This is only for to help you understand. If without this you understand, ignore this. And if you are still using my way of understanding, please don't believe that in reality V is 0. It's not. Just to help you go think in a particular direction, I'm asking you to do this exercise. I hope this makes things more clear. Any questions? Fine. student to ask the question. Yes. Does it make it clear? You ask the question. What's your name? Divesh. Has it helped? If not, please come and talk to me again after the class. Okay. All right. Coming to governing equation of V. This will be our starting point. Differential form of RTT. We have to make some judgments. What judgment? To get equation of V, what should be my entity? I will keep the entity as momentum. And it is a vector, so momentum vector. What will be phi? Rho times V vector. That's also a vector. Phi is also a vector. What would be the units of phi? Just to make sure we are understood. Kg meters per second per meter cube. Very good. Per meter cube, because it's phi. But what is here? What is the SI unit at this level? Kg meters per second. This is actual momentum, amount of momentum, quantum of momentum you have. Fine. So here phi will be replaced by rho v. The next question is what should be R2? I have said this 2-3 times by now. Non-advective flux reason for change in the momentum of mass that is currently residing inside the control volume. Euler's first axiom gives me the answer. And that I write as F external. What is F external? It is the net external force acting on the mass contained or residing currently inside the cuboidal control volume. As I was saying in the morning, there is one small fluid element which is resident of that control volume at this instant, and sooner or later we will have to draw the free body diagram of that, putting all the external forces and then representing them appropriately in terms of pertinent quantities, so that this equation which right now with F external has become this, but I'm not happy with that. I want more clear representation of what F external would be for a small chunk of mass that is currently inside that control volume. Okay, we will work on that. But before we go that, first make sure we are going from here to here. Things are clear. Please check what changes are appearing and whether those changes are in line with whatever I have here or not. Is it fine? Okay. So now let's work on F external. Left hand side is a done deal. Done deal in the sense I have operators acting on my variables of interest, whether it is V or rho. The left side is done deal. Right hand side requires harder work, more work. Okay, before I talk more about F external, I have in this slide what I am showing you is this equation is a vector equation. Do you agree with me? Is a vector equation. Vector equation like F vector equals mass time acceleration vector. I call that as a vector equation. One vector equation. But if you use a working coordinate system such as a frame fixed Cartesian coordinate system, we are aware that one vector equation gives rise to multiple scalar equations. How many? 3, right? तीनों अलग अलग डायरेक्शन में 3 इंडिपेंडेंट इक्वेशन मिलते हैं with one vector equation. Those three independent equations I am presenting here. So my working coordinate system is a frame fixed Cartesian coordinate system right here. And also I keep this in mind, that the unit vectors of a frame embedded Cartesian coordinate system will not change with time. I know that. They will not change with any of the spatial coordinates either. And I write V as this form, V in this form, V1, E1, V2, E2, V3, E3. And I write F external as F external 1. Here it is vector, mind you, this is vector. Now I'm writing as F1. So this is a scalar component. This is the scalar component, F external E1, F external 2 E2, and F3 external E3. Yes, in terms of scalar components. If you use all this, put it here, you can extract out these three equations. Right? Basically, what will happen, you will after substituting all this, you will club the coefficients, all the coefficients of E1 together on the left hand side, E2 together on left hand side, E3 together on left hand side, and same thing you will do on the right hand side. And then you will say that E1, E2, E3 are mutually perpendicular. That's why coefficient of E1 on LHS should be equal to coefficient of E1 on RHS. That equation will give you this first one. Same argument you put and equate the coefficients from two sides. This is what you will get, and same on E3 for the E3 side. Okay. Coefficients of E1 on LHS, RHS gives this, and similarly the other things. Do this exercise at least for once. Okay. So now I need to find these things. Earlier I was saying I need to find the F external vector. Now I have changed that question, and I'm saying that I need to find F1 external, F2 external, and F3 external, these three components. Once I have them, I'll plug them back here, and I should have the equation I am chasing behind. Yeah. Now let's focus on external forces. External forces, so we leave this equation on the side for the time being and dive deep into learning what those external forces are and how to represent them mathematically. Once we learn all that, we will come back and complete this equation. Now, Devesh was asking this question also in the morning, that when I say external forces, who is exerting those external forces, right? The answer will come from this slide. So we identify or realize again that there is a fluid element coinciding with it. That's the chunk of mass at time t. There is a fluid element coinciding with that. A fluid element has numerous fluid particles. We have discussed this concept. It's like an hierarchy. Fluid particle, and then you go to fluid element. A fluid element has several fluid particles. All those fluid particles make that fluid element, of course, at this point. One type of external forces is what we call as body force. What is body force? Forces that act on every fluid particle of that Fe that is residing inside the control volume. Example, gravitational force. There are numerous fluid particles on the surface of the fluid element and well within, inside the fluid element. But all of them are having this force acting, where MP is mass of fluid particle. And suppose gravity is acting downwards. Every fluid particle is experiencing that force. Since every fluid particle, whether lying on the surface of fluid element or well within, inside the fluid element, is experiencing gravitational force, that's why we call such a force as body force. Entire body of the fluid element is experiencing that force. Okay? Gravitational force is an example, and that's what we will come across almost all the time, especially as civil engineer, even as aerospace engineer, I would say. Gravitational force. We want to take that into account. If water is flowing in this room, of course gravity is acting. It should appear somewhere, and this is the place it is going to appear. The other type of forces, what this fluid element is experiencing, external force, is what we call as the surface forces. What are surface forces? Forces that act only on those Fp of this fluid element that are currently lying on the surface of the fluid element. You understand this? If this is the fluid element, it has fluid particles everywhere, but there are some which are right on the surface, right? Surface forces are those forces which are experienced only by these fluid particles which happen to be on the surface of the fluid element. Fine? Body where sab kuch tha, everybody was experiencing. Here only some special Fps are experiencing which are on the surface. Who is exerting that surface force? Yahan to clear hai, ye gravity, ye earth is drawing, earth is pulling every fluid particle. Surface forces kaun exert kar raha hoga? Yes, yes, the neighborhood, the fluid neighborhood. क्योंकि ये तो हमने कॉन्सेप्चुअली बस आइडेंटिफाई कर लिया हमारा ये सिस्टम है, बट दिस फ्लूइड एलिमेंट इज इंटरैक्टिंग विद अदर फ्लूइड एलिमेंट्स, अदर फ्लूइड पार्टिकल्स, but the force that those fluid particles exert, they don't exert it on a fluid particle which is inside this fluid element. कोई इंटरैक्शन नहीं है. नेबरहुड का इंटरैक्शन सिर्फ उन फ्लूइड पार्टिकल्स के साथ है जो इसके सरफेस पे. मेक सेंस? इफ आई कट दिस book and then I say what is the force exerted by the right side on the left hand side, that force will be coming on which particles which are right on the surface of the left part, right? जो अंदर है उस पे तो force नहीं आएगा. That's the reason it's called surface forces. And just to complete it, these forces are exerted by the Fp's of neighborhood on the Fp's of this fluid element. This means just show कर रहे हैं. Okay. We will see these two types of forces will have very different mathematical representation, and that is why I want to classify and treat them in a different way. All right, let's talk about body force now. So this is the way I'm going to split the vector F external, external body, external surface, and I do assume that the external body force is the gravitational force. As I said, that's what we will encounter almost all the time. My claim is that the external body force that this fluid element is experiencing is delta m times g, where delta m is the mass of the fluid element. As simple as that. Delta m times g. What is that delta m? There is no place for delta m in my final equation. Delta m to सिर्फ एक ऐसी transition है. I need to get that in terms of the variables of interest. Indeed, delta m can be written in this manner. Make sense? Density at the centroid of this control volume. And since this control volume itself is very small, I simply multiply that value with the total volume of the control volume. And that's what it is. It is small, fine. Whatever it is, we will take it forward. So delta m is this, and thus external body force, I am going to write it like this, where this should be a vector. Cut gaya niche. Under bar G. Now I'm not saying G is always along E3. I'm keeping it general. Right? Sometimes you will choose a coordinate system such that G is not along minus E2 or E minus E1. It may be in some direction. So let's keep it general. And then I'm going to write this vector as right, and then this is the expression I get. Ready? Not much hard work for at least for body force, and if the force, that body force is gravitational force. Rho times delta x1, delta x2, delta x3, g1 e1, g2 e2, g3 e3, full vector. अब ये वाला पार्ट निकाल लेंगे, ये वाला पार्ट निकाल लेंगे, तो we can go back and put in this equation में आ जाएगा, 2 वाला दूसरे में आ जाएगा, 3 वाला तीसरे में आ जाएगा. But that is only about body force. Now let's talk about surface forces. Yeah, this file is done. File manager. Okay. Surface forces. Now, surface forces are not straightforward to represent. For that, we need a new concept altogether. I'm going to define a new tensor called the stress tensor, with which I will try to write expressions for the surface forces. All right. Okay. So the symbol for the stress tensor will be this sigma. I have written xt. Xt ka matlab hai this is also going to be an Eulerian variable. It means it will change with time, it will change with location, and at any given location it may change with time also. Second order tensor. Now since my working coordinate system is currently Cartesian, frame fixed Cartesian coordinate system, the representation of this tensor is going to be in this manner, second order tensor. Right? Sigma ij, eij. Sigma ij, if I want to make a sentence, ijth scalar component of sigma xt in frame fixed Cartesian coordinate system. Surface forces acting on the mass residing inside the control volume are expressed using various sigma ij components. There are 9 of them because it's a second order tensor. Now at this point I am reminded I have been waiting to make a clarification to the class, and it becomes extremely relevant at 2:45 when I return back your quiz. Some students were arguing with me, and do argue. I like that, but I have the correct argument with me this time. When I say argue with me, don't take it in a negative manner. I mean, they were asking me questions and I enjoyed discussing with them, and I want to clarify. Students were saying that if I write sigma ij ei ej, what's the order of the tensor? If I just give you, I'm not saying it's stress, just sigma ij ei j. Tensor का order क्या है? Second order. कैसे infer कर रहा हूँ? Dyad. फिर दूसरा क्वेश्चन है, हाउ मेनी टर्म्स आर इन दिस समेशन? 9 है, ठीक है, सो फार सो गुड. कोइंसिडेंटली दोनों आंसर करेक्ट है अभी. 3 to the power 2 terms in the summation and second order tensor. ये वाला 2 और ये वाला 2 मैच हो गया इस केस में. I give you something else. I asked the first question, order of tensor. Everybody agrees? कोई dispute नहीं है क्योंकि dyad आ रहा है, second order tensor. Now comes the other question. How many terms are in this summation? 27. Why 27? Because the number of terms in the summation is controlled by not this number, but by 3 raised to the power hash, where hash is the number of repeated indices, which in this case is 3, I, j and k. So 27 terms हैं इसमें. Who disputes this? There were some people who were disputing, but I think they have learned by this time. They were saying that हम इसके 27 terms में से कुछ terms को club कर दे सकते हैं, and then I will have 9 terms which will have, I mean even कि coefficient के अंदर 3 term होंगे और फिर even E2 के अंदर भी 3 term होंगे, और इसलिए मैं कहूंगा कि इसमें 9 terms है. ये आपका अपना इंटरप्रिटेशन है, आइंस्टाइन नोटेशन का हिस्सा नहीं. आइंस्टाइन नोटेशन में जब हम कहते हैं समेशन तो 3 raised to the power 3 जाता है. Let me give you a counter example if there is still somebody who has doubts about it. Going by that argument that some students presented, I want to ask them, A dot B अगर मैं लिख रहा हूं where both A and B are vectors, in index notation what will that be? AI BI? AI BI? Order tensor का क्या है? 0 है. कोई यूनिट वेक्टर है ही नहीं. नंबर कितने हैं समेशन में? 3. तो जो लॉजिक आप मुझे पहले दे रहे थे उस हिसाब से तो इसमें एक ही टर्म 0 टर्म होना चाहिए, 0 होना चाहिए क्योंकि ऑर्डर टेंसर का 0 है, राइट. सो काउंटर एग्जांपल. सो बॉटम लाइन इज बोथ आर इंडिपेंडेंट. नंबर ऑफ टर्म्स कितने होंगे एक समेशन में और वो ऑर्डर क्या है टेंसर का, दोनों इन जनरल दो डिफरेंट चीजें. कभी कभी कोइंसाइड हो जाता है जैसे यहाँ पे कोइंसाइड हो रहा है, ठीक है. Give me 2 minutes to introduce this idea of the stress tensor. Sigma ij तो बस एक symbol है, right? Sigma ij is just this a symbol. What does it actually mean? And how, after all, at the end of the day, please don't talk. How, after all, at the end of the day, I'm going to relate sigma ij's to surface forces. So I need to define it carefully. How do we define stress tensor in a fluid? Suppose there is this fluid bulk. पूरे रूम में fluid है. May be moving, may not be moving, doesn't matter. I consider an imaginary plane and cut the entire fluid bulk into 2 parts. Imaginary, अपने दिमाग में. Separate them. Okay. Now the way I have cut the whole bulk, I have cut it using a plane. And since it is a plane which cuts, I can associate a unit vector with that plane. All right. That unit vector I call En. I am saying that after I cut this, I make 2 parts of the bulk of the fluid, the left part and the right part. The left part has outward unit vector. So En is outward unit vector. Cut करने के बाद outward unit vector. For the left part, En is E1. For the right part, En is minus E1. Right? Fine. Now, on this, let's focus on the left part now. Left part, on the left part, let's focus on the left part, and on the left part, focus on a point P. ये यहाँ लिखा हुआ है. And let's consider a small area delta A around it, such that P is the centroid of that small area. Okay. Now, this small area, after cutting, if I want to draw the forces that the right part was exerting on the left part through this area, those forces are written here. Forces hoga, right? Internal forces. That's what I was talking earlier also. If there is this book, gravity is acting, external force is gravity. But if I cut this book into two halves, यहाँ से काट कर दो हिस्सा बना लो, and then I have to draw the free body diagram of only the left part, the gravitational force on the left part will be an external force, but the force that the right part was exerting on the left part is also external to the left part. You agree with me? जब मैं पूरी चीज को फ्री बॉडी ले रहा था तब वो फोर्सेस मुझे नहीं लिखने थे क्योंकि वो इंटरनल फोर्सेस थे, लेकिन अगर लेफ्ट पार्ट को सिस्टम बनाना है तो राइट पार्ट जो फोर्स एक्सर्ट कर रहा है उससे एक्सटर्नल फोर्स में लाना पड़ेगा. यू एग्री विथ मी? इट शुड बी काउंटेड. आई एम सेइंग that delta F1, delta F2 and delta F3 are the three components of the force that right part was exerting on the left part only through that small area delta. अब अगर मैं यहां कुछ एरिया ले लूं तो यहां भी कुछ फोर्सेस आएंगे. आई कैन कॉल इट डेल्टा F2 प्राइम in this direction and delta F1 prime in this direction and so on. But I am not worried about all the area on this. I am worried only about the shaded area. Why shaded area? Because shaded area is in the neighborhood of point P, and right now I am saying that P has coordinates x1, x2, x3. I am focusing on this point. Okay, delta F1, delta F2, delta F3. Now if I go and try to draw the free body diagram of the right half जो काटने के बाद बना है, and I focus again on the small area in the neighborhood of point P, that will be having some forces which are being exerted by whom? Left part on the right part. और वो forces equal and opposite होंगे जो right वाला left पे डाल रहा था. न्यूटन्स थर्ड लॉ. ठीक है, वही मैं अभी यहाँ ड्रॉ करके दिखा रहा हूँ. डेल्टा F1 इस दिशा में, डेल्टा F1 यहाँ पे इस दिशा में, एंड सिमिलरली F2 and F3.